Hello guys, welcome back to your channel Learning Point, and today we are discussing exercise 3.3, the continued part of 12th Commerce new syllabus, the board book that has been issued by the government. Question number 3 today has asked us to find the value of dy by dx. Before we start, I'll like to inform you something. The question number 1 and 2 of this exercise have been given in a different video. I am giving a link for that particular video in the description box. Please check out the description box, check out the link, and also if you wish to study the derivatives basics, otherwise the composite functions or the inverse functions of derivatives, I am giving the link of all those lectures in the description box. Please go to the description box, check out all those links, and I'm sure you would be able to understand all the points very clearly and very nicely. Let us start with question number 3. Sub number 1 says y is equal to log of x to the power x plus x to the power log of x. Up till now, all the sums which we did, we used to take the log directly, but here I cannot take log directly for the reason that I have a property of log which is like this: log of m into n is equal to log of m plus log of n. But this cannot be equal to log of m plus n. Now because this is not getting applicable over here, direct log is not possible. So what we do is we say let a is equal to the first term, which is log x to the raised to x, and b is equal to second term, which is x raised to log x. So according to this, your value of y will become a plus b. We are interested in the value of dy by dx. So we will say over here, differentiate with respect to x. So derivative of y is dy by dx. Derivative of a is dA by dx, and derivative of b is dB upon dx. We give it as equation number 1. We will find the values of derivative of a and b separately, and we will substitute those values in equation 1 to get our final value of dA by dx, dy by dx. So let us start with the first term. We will say over here, consider a is equal to log of x to the power x, and you can see the question is in the form of fx raised to x, variable raised to x, function raised to x in fact. So whenever the variable is in the power, we have to always simplify that by taking log on both the sides. So we will say over here, taking log on both sides, derivative, the value over here will come out to be log of a is equal to log of x, in fact log of log x and whole power x. So what happens over here is the power goes behind the value of log. So the answer that I get for log of a is x into log of log x. So now over here any further simplification is not possible. So what we do is we consider this is u, this entire term as v, and therefore we differentiate this with respect to x, so derivative of log of a is similar to the derivative of log of y, which was 1 by y into dy by dx. So here it is 1 by a into dA by dx. When we apply the multiplication rule, this is log of log x multiplied by the derivative of x plus x into derivative of log x. Now this 1 by a into dA by dx comes down as it is. Log of log x also comes down as it is. Derivative of x is 1. This x comes down as it is because it is outside the derivative sign, and this term over here becomes log of fx. So the derivative of log fx is 1 upon fx. So I get 1 upon log x multiplied by derivative of fx. So it is derivative of log x. Cross multiply this a on the opposite side since we are interested in dA by dx. So this is a into log of log x plus x upon log x multiplied by 1 by x. So yes guys, definitely you can cancel off these both x terms, and again over here we will substitute the value of x, in fact value of a. The value of a was log of x to the power x, as you can see over there. So log of x to the power x multiplied by log of log x plus 1 upon log x. And give this as equation number 2. After that, we will same way also find the value of derivative of b. We consider over here b. You can check, it is x to the power log x. Again, it is variable raised to a function. So when it is variable raised to function, again we have to take log on both the sides first of all. So value of log b over here, and yes, you can use a shortcut. Directly you can take this log x on the back side over here, and again multiply this with log x. So yes guys, if you observe the sum carefully, it becomes log b is equal to log of x the whole square. Now, how do we differentiate this? Let us see. Come on, let's go. I will say over here, differentiating with respect to x. Left hand side, as you already know, it is derivative of log b 1 by b into db upon dx. But right hand side is very important guys. Log x is a function of x. So I will have to consider this in the form of fx raised to n. And derivative of fx raised to n, as you already know, it is n into fx to the power n minus 1 multiplied again that by the derivative of x. So this over here is 2 into log x to the power 2 minus 1, which is 1, multiplied by derivative of fx, which is multiplied by derivative of log x. We will cross multiply this b on the opposite side. So I get dB upon dx is equal to b into 2 log x into 1 by x. Now what I can do is I can resubstitute over here the value of b, which is x to the power log x into 2 log x, and 1 by x can be taken as x to the power minus 1. Now these both terms, I can use the property of indices or the rule of indices, as you say, a raised to n is equal to a raised to n plus n. So log x plus negative 1 together, it will become x raised to log x minus 1 multiplied by 2 log x. So this over here, guys, becomes your equation number 3 and the value of your dB upon dx. Now we will substitute equation 2 and equation 3 in equation 1. So what is the derivative of this? I will get dy by dx is equal to a log x to the power x and the bracket term log of log x plus 1 upon log x and the second element over here that you have x to the power log x minus 1 multiplied by 2 log x. So that completes your answer for the derivative of y. As you know, we have a tendency to box our final answer. So that goes inside the box and we highlight that. So that is your sum number 1 of question number 3. I'm sure you can see it's a very small sum. For 4 marks, guys, this kind of sums will come for 4 marks. You have to solve this kind of sums very carefully and very patiently. 100% you will get the answer if you are patient enough to solve this kind of sums. Let us see our sum number 2. Sum number 2 says y is equal to x raised to x plus a raised to x. So over here, once again, as I told you for the first question, direct application of log is not possible, and therefore what I have to do is I have to consider, let us consider P and Q because the question is using the letter A over here. So that you guys don't get confused, I will use it as P and Q. But believe me, that won't make a big difference to my answer. Whether you take derivative of that A value or you take the derivative of P, ultimately it is always going to remain the same. So I consider P is equal to x raised to x and Q is equal to a raised to x. So therefore y is equal to P plus Q. As you all know, we are interested in the value of dy by dx. So we will differentiate this with respect to x and the derivative of y, which is equal to dp by dx plus dq by dx. Therefore, now we will say consider p, which was x raised to x, and therefore I will get take log on both sides log of p is equal to log of x raised to x. As per the property of log, this x variable goes behind the log and it becomes log p is equal to x times log of x. So guys, once again, we consider this is u and this is p. So derivative of log p, when I want to find, I have to find right over here differentiating with respect to x. Log p, it is 1 upon p into dp by dx. And here we will apply the multiplication rule. So I am sure everybody now is very confident about the rule. V derivative of u, so log x derivative of x plus u derivative of v. So x into derivative of log x. Cross multiply this p on the opposite side, guys. dp by dx is equal to p into bracket log x into 1 plus x into derivative of log x is 1 by x. Cancel off this x and x element and resubstitute the value of p over here. dp by dx is equal to x raised to x and the bracket element is just log x plus 1. That is your equation number 2. Now I will say consider q. Q, as you know, it is a very basic function a raised to x whose direct formula for the derivative is available, so we don't need to apply log over there. Directly we will say differentiate with respect to x. So derivative of q over here is dq upon dx and this over here is a raised to x into log of a. That becomes your equation number 3. In order to get the final answer, we say that substitute 2 and 3 in equation 1. So the value of dy by dx is equal to x raised to x and bracket log x plus 1 plus the value of dq by dx, which is a raised to x into log of a. And yes, we are done with our answer. So as usual, we will be putting our final answer in the box and highlight that. So that is your sum number 2. Guys, in case if you feel to write this particular sum, just pause the video in between, make your own notes in your handwriting, and then once again move on to the further part so you can learn the entire thing very nicely, very properly. Let us see the last sum of this exercise, which is y is equal to 10 to the power x and again to the power x plus 10 raised to x raised to 10 plus 10 to the power 10 to the power x. Yes guys, again we have to break it into 3 parts like we did in the previous 2 sums. We used to take a and b, otherwise p and q, whatever you like the variable you can take. So here again we have to break it into 3 parts. So I will consider over here that let a is equal to 10 raised to x raised to x, b is equal to 10 raised to x raised to 10 and c is equal to 10 raised to 10 raised to x. Therefore, y is equal to a plus b plus c, and therefore when we differentiate this with respect to x, dy by dx is equal to dA by dx dB by dx plus dC by dx. So let us start with considering the value for a. We will say over here consider a is equal to 10 raised to x, and now because we can see that it is function raised to a variable, so obviously we have to take log on both the sides. So I get over here log y, in fact log of a is equal to log of 10 raised to x and raised to x. Now the thing is, as per our property, we have to consider the entire power as one term. So we consider x raised to x as one term, 10 as a separate term. So it will go behind the log. So it will become x raised to x into log of 10. But that is your value of log of a. Here the problem is, once again I am having x raised to x. So again taking log on both the sides. So this will become log of log a is equal to log of x raised to x plus log of log 10. I'm sure you can make out the property, which is log of m into n, and that is log of m plus log of n. So this x will go behind the log and it will become x into log x plus log of 10. So now guys, any further simplification is not possible. So I will differentiate. So when I differentiate, I consider this as u and this term as v. So let us start. Differentiate this with respect to x. The value of log y will be 1 upon log of a into derivative of log a, which is 1 upon a into dA upon dx. Guys, I am directly writing the answer. In case if you wish to understand this more in detail, I would suggest refer the first video of this particular exercise. I have given a detailed explanation for this over there in that video. I am giving the link for that particular video in the description box. Please check out the description box written as exercise 3.1 question number 1 and question number 2. So you would be able to get this kind of a sum over there with a given proper detailed explanation. Okay guys, let's continue. Over here, when I want to apply the multiplication rule, it is v into derivative of u. So it is log of x into derivative of x plus x into derivative of log. That was your first term. Now let us discuss about the second term. This 10 is a constant number, and therefore this entire term over here becomes a constant. And if this entire term over there becomes a constant, and we know that derivative of a constant is 0, so I get just a 0 over here, and we can ignore that from the next step onwards. So that is your value of log 1 by log a into 1 by dA by dx. Cross multiply this on the opposite side, guys, because we want the value of dA upon dx, which is equal to a into log a, and inside the bracket log x into 1 plus x into 1 by x. Cancel off the values of x and substitute the value of a and log a. So guys, what was the value of a? It was 10 raised to x, and log a was x raised to x log 10. So let us write. So that becomes your equation number 2. Now let us see what is the value of b. It is 10 raised to x raised to 10. Once again, I will say over here, consider b is equal to 10 raised to x raised to 10. So now over here, I have to take log on both the sides. Just in order to simplify and take the power in the base. So I get log b is equal to log of 10 raised to x raised to 10. So with the property of log, I can take this element behind over here. So this becomes x raised to 10 multiplied by log 10. Now what happens over here is, because log 10 is a constant, we consider this entire term as a coefficient element. Why we consider it as a coefficient? Because in the basic, the first lecture of derivatives, I have told you whatever term is multiplied with the variable is called as a coefficient, and whatever term is either added or subtracted is called as a constant. So here I can see that there is no addition or subtraction, but definitely there is a multiplication. Therefore, if I consider that this log 10 over here is a constant, so I can directly differentiate this with respect to x. And when I differentiate this with respect to x, I get derivative of log b as 1 by b into db by dx is equal to, because it is a coefficient, I write it first, so log 10, and for the second term I will apply the formula for x raised to n. What is the derivative of x raised to n? X raised to n, it is n into x raised to n minus 1. What is n? The answer is 10. So I get the value as 10 into x raised to 10 minus 1. Cross multiply this b on the opposite side. So db upon dx will become equal to b into 10 into log 10 and x raised to 9. Substitute the value of b, which is 10 raised to x raised to 10. So you get 10 raised to x raised to 10 multiplied by 10 multiplied by log 10 and multiplied by x raised to 9. Now guys, for these both terms, I can apply my law of indices a raised to m into a raised to n, which is a raised to m minus n. So it becomes 10 raised to x raised to 10 minus 1 as entire one term, x raised to 9, and I get this as log of 10. This becomes your equation number 3, the value of dB upon dx. Now last we have to find the value of derivative of c, and c was 10 raised to x. So now I will say consider c, which is equal to 10 raised to 10 raised to x, and as usual I have to take log on both the sides for this term too. So when we take log on both the sides, I get log of c is equal to log of 10 to the power 10 to the power x. Now I consider this entire term as a single unit, so it will come behind the logarithm. So that will become log c is equal to 10 raised to x into log 10. Once again guys, as I told you in the beginning, this will be considered again as a coefficient, and 10 raised to x is directly in the form of a raised to x. What is derivative of a raised to x? It is just a raised to x into log of a. So when I differentiate this with respect to x, derivative of log c will be 1 by c into dc by dx, and this over here is straight away 10 raised to x into log 10 into log 10. So guys, we can combine these both log 10 values and cross multiply this c to get the value of dc by dx. C into 10 raised to x multiplied by log 10 the whole square. Just substitute the value of c guys, and you are ready with your value of dc by dx, which is 10 to the power 10 raised to x again into 10 raised to x and log 10 the whole square. Students, once again for these both terms, I can use my property a raised to m into a raised to n, which is a raised to m plus n. So this entire is the value of m, and this is the value of n, and therefore dc by dx is equal to 10 raised to x plus x multiplied by log 10 the whole square as equation number 4. Finally, we will say substitute 2, 3 and 4 in equation 1, and we get our value for dy by dx. Let us be very careful guys. Let us see what is the value of equation number 2 over there. It is 10 raised to x into x raised to x into log 10 and there were also some bracket terms. Let's check out. just log x plus 1 plus the second element, which is 10 raised to x raised to 10 minus 1 multiplied by x raised to 9 into log 10 and the last element right there in front of you, 10 to the power 10 raised to x plus x multiplied by log 10 the whole square. So guys, that completes our exercise 3.3. Next time we'll meet up with next type of a function. Till then, everybody take care, stay home and stay safe. Thank you.